How do hot water cylinder coils work? In this short video, we will look at one of the most important components found in all indirect cylinders, the coil heat exchanger. Above all else, this single component will define how a cylinder performs and which applications it can be used for, depending on these three important factors. 1. The kilowatt rating of the coil. 2. The design of the coil. And finally, the number of coils inside the cylinder and how they are configured. First, the coil in its most basic form is made of a simple pipe with one helix turn and joined to two Boss connections, one at each end. This connects to the flow and return of the heat source, usually a boiler. The kilowatt rating of the coil can be changed by increasing or decreasing its surface area. The more surface area, the greater the heat transfer is, the higher the kilowatt rating. Bear in mind, the kilowatt rating is only an indication of the maximum potential output. It needs energy from the heating system in the form of the right water temperature, flow rates, and pipe sizes in order to achieve it. The four most popular ways to increase the coil surface area: 1. Extend the length of the coil by adding more turns. Note that to save space, coils can be coiled back on themselves using a coil-in-coil design like this. 2. Using a larger pipe diameter is another option to provide more surface area. This has the added advantage of allowing greater flow through the coil, but can be limited by the extra weight of the coil and how tightly the pipe can be bent. 3. Some manufacturers use a corrugated pipe or one with fins to increase the surface area. These pipes are very flexible and provide a solution where very large surface areas are needed, such as for a thermal store. However, the pipe is intrinsically flimsy and will shake about inside the cylinder even when supported by clips, making the coil more prone to leaks. The ridges can create turbulence, resulting in noise and reduced flow rates, as well as trapping limescale, leading to reduced heat transfer over time. 4. The final common way of increasing coil surface area is to use a manifold design, with multiple pipes linking into two manifolds at each end with Boss connections. These can be just a few pipes or lots of very small ones, allowing you to achieve a very large surface area inside a very small amount of space. The small bore version restricts flow rates, resulting in a high-pressure drop across the coil. The manifold design can also shorten the working life of the cylinder. Having a large coil surface area and a high kilowatt rating is important for heat pump cylinders because they work at relatively lower temperatures compared to a conventional boiler, meaning the coil needs to transfer as much heat as possible. High kilowatt ratings are also essential for thermal stores and are most often used in copper cylinders to compensate for when an undersized cylinder is used due to insufficient space, to help achieve the required volume of hot water with a faster heat-up time. Moving on now to the coil design factor, its pitch. The coil pitch determines the application a cylinder can be used on. Although less important now as modern systems use a circulating pump, old gravity feed systems require a coil with a higher pitch so gravity can pull the water through. Gravity feed systems also can't benefit from space-saving coil designs such as coil-in-coil. On a modern pumped system, an excessively long coil can be self-defeating if the pitch of the coil becomes too tight. It will interfere with the circulation of the water around the coil and can result in slower heat-up times. Finally, let's look at the different options available for twin and triple coil cylinders and how multiple coils can be configured within a cylinder. In tall cylinders, coils can simply be stacked, one on top of the other. Stacked coils can have a dedicated volume of water attributed to them, for example in a solar system. The alternative is to interlace the coils so one fits alongside the other at 90 degrees or more commonly at 180 degrees. This saves space but means you can't dedicate volumes of water to a specific heat source. That covers all the basics about coils and how the number, surface and pitch impact cylinder performance and applications. We hope you found it useful.